All right. So polygon has to be a closed figure. All right. And the sides that have a common endpoint are non-collinear. It just means like you can't have like sides that overlap and you can't have any sides that intersect. Okay, so it's a closed figure with finite number of segments. Anything that has a curve, right, isn't going to be a polygon. Okay, we also did convex versus concave. Sound familiar? Yeah. Okay, so concave are when two sides, if you extend them, so like here's concave, they cross over each other. Versus if I extend all the sides in this polygon, notice none of them are gonna cross each other. Okay? Whoops.
Like within the polygon?
Within the polygon. Like when I think of concave, I think it caves inward at some point. Almost everything that we'll work with will be convex. Right? But you still need to be able to tell the difference between the two. All right. Okay, now we're going to get into the new part, which is the interior angles of a polygon. Okay? It has to do with how many triangles you can form from one vertex of the figure. Okay, so let's look at a triangle. We should know how many degrees does a triangle add up to? 180. Okay, so here we have 180. What about a quadrilateral? Well, yeah, 360 because I can create two triangles. And each of those triangles has to be 180. So a quadrilateral, no matter what it looks like, has to add up to 360. Okay, what do you think for a pentagon then? 520? Close. 540. Yeah, because we have 180 at each of these. So that will be 540. There is. We're going to see it on the next page. Hexagon. What's another 180 added to that? 720. Okay, and hopefully these names of the polygons, we might need to revisit them. They're on the next page. These are the ones that we needed to know from the first chapter. We might just have to revisit a couple of them. Heptagon is an unusual one. That was 7 sides. What else? Nonagon maybe, 9 sides. And then remember, decagon is 10. Dodecagon is 12. Any other number of sides, we just put G-O-N at the end.
Why do we not use 11?
It's just not a very common figure that shows up. There is a name for it. I don't remember it. Listen, there are names for other polygons, but I don't need you to know them. I don't know them.
But
like,
would I put 13 gone? Is that what you're saying?
That's what I'm saying. So like, let's say if you had a 16-sided polygon, I know it has a name, but I don't need you to know that. I would just say 16 gone. But all the ones on here, you do need to know. Okay, so let's see if we can find the pattern, and then I know the formula is in the box below, but let's see why that's true. Okay, so we said a triangle has 3 sides, so we said that adds up to 180. A quadrilateral has 4 sides, 2 triangles, so it has a sum of 360. A pentagon, how many triangles? 5 sides, but how many triangles? 3. And we said that was 540. This one had 4 triangles. Okay. So what do we notice about each of the triangles according to how many sides?
They're just going up by 1.
They're going up by 1. So this will have 5. This will have 6, 7.
What do you
Yeah.
put at the end?
Okay. So if there are n number of sides, how many triangles are there?
We don't know. N minus 2.
Well, what do we notice about the relationship between these two numbers going
There's
across?
2 more sides.
There's always two more sides than there are triangles. Or if there's 9 sides, subtract 2, we get the number of triangles. Okay? So if we kept going, for example, a heptagon, we could multiply 5 times 180, right? Because if each triangle adds up to 180.
Is this chapter where you're able to use calculators?
Yeah. This one will definitely have calculators. So 5 times 180 will give us, and we would keep going. So that means for any polygon, we would take n minus 2 times 180. Or I have it here. 180 times n minus 2. Doesn't matter which order we put them in, right? Because commutative property. So where n stands for number of sides, s just stands for the sum. Now be careful, these are interior angles. Later we'll look at the angles on the outside. Okay, so let's find the sum of the measures of the interior angles of each convex polygon. So for the first one, so our sum, so again, 16 is the n, so it's 16 minus 2 times 180. So 14 times 180, 2,520. Which is a big number. What's happening? Because the more sides you have, the bigger the sum is going to be. All right, this one just says 8x. That's fine. We could still write 8x minus 2 times 180. So we're just going to distribute. So 180 times 8x, 1440x minus, what's 2 times 180? 360. Okay, we want to find the measure of each angle in this shape. How many sides do we have? 4 sides. So this is a quadrilateral. So this means our sum has to be 360. So we have x plus 2x plus 2x equals 360. So kind of like when we did triangles, right? All the triangles have to add up to 180. Here, all the quadrilateral angles have to add up to 360. Okay, I gave you pretty easy numbers here. What do we get for x? Yeah, 60. Good. Okay, so that makes what two angles? 60? A and D. And B and C both have to be 120. How could we check our answer? Add these all together and we should get 360. Cool. Any questions? All right. Okay, how many sides do we have this time? 6 sides. So the sum is going to be 6 minus 2 times 180. Again, you can also look back at your table and figure it out. But right? Like you could just plug it into the formula. So 6 minus 2 times 180. So that'll be 4 times 180, which is 720. Now I have how many angles that are 9x plus 30? 4 of those. So I would rather just do a 4 times 9x plus 30. And I have 2 angles that are 2x. And those all have to add up to 720. Distribute, right? What do we get for x? Good. We get 15? All right. So if x is 15, well, the two on the ends will just be 30 and 30. So j is 30. M is 30. Because 2 times 15. Yeah, so these two will be 30. Okay, now 9 times 15 plus 30. What are all the other angles? 165. Good. So if you have something other than a triangle, we have to figure out, right, what the sum is going to add up to, and then we can solve from there. Okay, another definition to revisit. Regular polygon. Regular? Sound familiar? Okay. What do we know about regular? Right. We can also say that this is equiangular and equilateral. So all the sides are congruent, all the angles are congruent, and one more additional piece at the beginning. It's only true for convex, right? We can't have a concave regular polygon. So here's an example of a regular pentagon. Okay, so what if we want to find just one? So notice all of these angles are going to be the same. How could we figure out what each of these interior angles would be? What do you think?
When you figure out this is a pentagon, when you realize that it's 5 and you do that as equals
Yep.
5 minus 2.
So if we could figure out what they all add up to, and we divide it equally. So this is going to be 540. So all 5 of these angles add up to 540. So if I want to find one interior angle, 5, and that will give us 108. So that means every angle in here is 108 degrees. So anytime we have a regular polygon, we should be able to figure out what each interior angle will be. So can we come up with a formula for that? Okay, so let's say, remember what the sum was on the previous page? 180 times n minus 2. Do you want, actually, I'm going to put n minus 2 times 180. And then what do I want to divide by? Yeah, how many angles there are. So where n equals number of sides. Okay, so what if I gave you the measure of one interior angle and we want to figure out how many sides it has? But this is not n. We want to figure out, in this case, find the number of sides. So we're trying to figure out what is n equal to based on that. We reverse it. So in other words, this is equal to n minus 2 times 180 divided by n. So we don't know what n is. That's what we're going to solve for. Okay, so now we have an algebraic equation. More than one way to solve this. What would you guys do? You want to distribute? Okay, we can do that. We don't like this one. You want to, okay. You don't like the fraction. Okay, how can we get rid of the fraction? We can multiply the other side by n. Some people like to even think of it as, you can also just think of this as cross multiplying.
I love that.
Right? So if you have a fraction on one side, you could always turn the other side into a fraction and then just cross multiply, because that would just be multiplying by 1. So I have 135n equals And it doesn't matter. You can distribute before doing that. The order that we do that in makes no difference. Okay, now I get 135n equals 180n minus 360. Now if I subtract 180n, I get negative 45n equals negative 360, or you can like swap it around, whatever, it doesn't matter. We should always get a positive number for n, right? It's not going to make sense if we have a negative number of sides. N equals 8. Good. Now I'm just going to go back, make sure, yeah, it just said find the number of sides. If it asked us to name the polygon, we would write octagon, but it just asked for what the number of sides. Okay, 156, same thing. So we're going to set this equal to n minus 2 times 180 over n. Same thing. We're going to put it over 1 and cross multiply. And let's see what we get.
I got
15. Let's take a look. Well, we subtract 180, that gives us negative 24n. Good, 15. Would we ever have an interior angle of 200 degrees? No. What's the most we would ever have an interior angle? 180. So that's what we will call, when we get to Algebra 2 and Pre-Calc, we talk about limits. We would never get an angle that's 180 degrees or bigger. What's the smallest the angle could be? No? For a regular polygon? What's the smallest number of sides you could have? 60. So no matter what, I would have to give you an angle measure between 60 and 180 degrees. Otherwise, those numbers wouldn't make sense.
But can't you have 60 and you can't have 180?
You can have 60. So that's why I called it a limit, because you can have an angle of 179.9999999. You just can't have 180. So, but we can have one that is 60. Okay, last thing for today is going to be on exterior angles. Okay, when we did exterior angles, we looked at only one exterior angle at a time. So, for example, if I were just to extend one side of this triangle, that would make an exterior angle here, right? Of just extending one side. What do we know about this exterior angle here?
It's greater than
Okay, good. So we remember it's greater than each of these. It's not only greater than, but it's also equal to whatever these two would be. Now, I'm going to use regular polygons just for this example, because we want to look at the sum of the exterior angles. So I'm just using these regular polygons as examples. So this was a regular triangle, meaning equilateral, equiangular. What would this exterior angle have to be? 120. Good, right? Because if all of these are 60 degrees. Okay, now I'm going to extend another side, so I'm going to go this way.
Wouldn't they all be 120?
They're all going to be 120. Then I'm going to extend this direction, so kind of like going around clockwise. What do we notice about the sum of the exterior angles? 120 plus 120 plus 120 is 360. Oh.
So that's 3 sides.
Okay, so now let's see if we have a regular quadrilateral, also known as a square. Let's extend each side this time. So this exterior angle will be how many degrees?
Wait,
No, just the exterior angle here. No, if this, all the angles on the inside are 90.
180.
Well, wait. These two angles make a linear pair. So if this is 90, this has to be 90.
Oh.
I know. I'm talking about each. We'll get to the sum. And then if I extend this side, this will be 90. Extend this side, this will be 90. So now I have my sum of the exterior angles is 4 times 90, which is also 360. So even though I added an extra side, the exterior angle still added up to 360.
Why are you not including all of the, wait, you only extend the sides and do it? You don't.
I extend one side at each vertex. So I get an angle here, one angle here, one angle here. Same thing for the square, except for now I have 1, 2, 3, 4 exterior angles. Do we see that? Now, if I have a hexagon, how many exterior angles am I going to have now? 6. So if I extend this side kind of makes a cool little picture here.
Actually cool.
Okay, now how many exterior angles do we have now? We have 6 of them, right? Just like the other ones. So what is the sum of the exterior angles? Well, I'll give you a hint. I'll tell you just so we know. Each interior angle is going to be 120 degrees.
Wait, I have a question.
They're all 60. Yeah.
So does all the exterior angles, are they all the same?
Only if it's a regular polygon. I'm using a regular polygon for our example. So that's what I just used regular polygons so we could examine each of these. So what I want you to just notice is with all 3 of these, we added more and more sides, but the exterior angle, they all added up to 360. So if I had 10 sides, what are all the exterior angles going to add up to? 360. So it doesn't matter. This is going to be, some people call it a trick question, but I always put one on the test and the quiz. If I say a polygon is convex, the sum of the exterior angles is always 360. So if I said to you, oh, what is the sum of the exterior angles of a dodecagon? 360. If I say, what's the sum of the exterior angles of a 24-sided polygon? 360. So every single time it's just automatically going to be 360. Versus the interior angles, it's going to be bigger and bigger depending on how many sides. Yeah, Maya.
So as you have more sides, the exterior angles get smaller and the interior angles get measured.
Like 1? Yeah. So as you add more sides, the exterior angles get smaller and smaller, and the interior angles get bigger and bigger. Yeah, absolutely. So what if we wanted to find just one exterior angle of a regular polygon? Well, 360 divided by n. Okay, oh, we're doing great on time. Okay, so last couple examples here. Given a type of polygon, I want you to find a measure of one exterior angle and one interior angle for a pentagon.
120.
What? Wait, for which one?
Pens is fine.
Okay, so pentagon, let's start with it has 5 sides. I want to know one exterior angle, 360 divided by 5. So for one exterior angle,
I mean 72.
72?
Yeah.
Now I also want to find an interior angle. Now I gave you a formula for that.
No, wait.
But what else do we see about interior angles and exterior angles? Yeah, so an exterior angle plus an interior angle is always going to be 180 degrees because they make a linear pair. So yeah, you could use the formula, but it's so much easier just to work with the exterior. It's going to be 180. So exterior angle and interior angles always make a linear pair. So these two are always going to add up to 180. Okay, how about a dodecagon? Now how many sides? 12 sides. So 360. So exterior angle, 360 divided by 12 is 30? Wait, did you divide?
I divided 180.
Oh. And then what about our interior angle? Yeah. Good.
We have 15 or
20. What time is it?
We have 12.
Oh, we have plenty of time.
Why do we have a review before
Why do we not have a review?
Not complaining, just curious. Because
Oh.
we don't have a review.
We have time. So I mapped out the second semester already to try to figure out like where we have a bunch of extra days. So even though there's more curriculum second semester is also longer than first semester. So we have a little bit more time, which is kind of nice.
Really nice. Wait, so we have no homework. Wait, what day is that? Thursday?
We have no homework Thursday, Friday.
Oh, there's also a typo on the lesson plan. It says collect 5-6 here. That's not right. We have a review day on Friday.
Why is that not right?
Because we have class. I'm just not collecting. It's right on my jag. Yeah. Yeah, that's a mistake. It's just the collecting of the homework. Okay, these are basically, this is the same. Or no, I'm sorry. This is, we know the number of sides. So this is n. Now I want you to find the same thing, actually. Yeah, measures of the interior and the exterior angle.
Wait, what's n sides?
N is the number of sides. So it's still easier to find the exterior angles first, right? 360 divided by 20, 18. And then what would the interior angle be? 162. Here, N is 18.
Yeah. So
And then the interior angle would be, good.